Today we are doing P3, Radicals and Rational Exponents, Day 2. And our learning goal is for you all to be able to rationalize denominators, evaluate, and perform operations with higher roots. So we're going to be looking at roots higher than a square root. So let's start off by rationalizing the denominator. And if you can remember, that means we're making the denominator or rewriting it so it doesn't have the radical. So let's try this one. And if you remember from Algebra 1 or 2, you multiply, when they say square root, you multiply it by itself. You have to do the top and the bottom. And you'll get 15 radical 6 over 6. Now, if these two numbers can be reduced, you always want to reduce it. So I'm going to divide them both by 3 and get 5 radical 6 over 2. Now, you can't divide what's under the radical, but you can divide what's in front of it. And then you're done. And then we can try another one. Now, some of you all would do it like this, and you would get 12 radical 8 over 8. What happens here is the square root of 8 can be simplified. So you're going to have to simplify that to 12 times the square root of 4 times the square root of 2 over 8, which gives us square root of 4 is 2. 2 times 12 is 24. Radical 2 over 8. And if you reduce that, we're going to get 3 times the square root of 2. Okay, so sometimes you have to simplify it in order to get your final answer. Okay, now what if you had two terms on the denominator? Like this. You're going to multiply by what we call the conjugate, which would be 5 minus square root of 3. And notice I didn't change the 5, I just changed the square root. Because if you change both of them, then the radicals won't cancel. So in the top, I'm going to multiply the 7 times the 5, which is 35, minus 7 times square root of 3, which is 7 square root of 3. And in the denominator, I'm going to FOIL it, but since they're conjugates, then all you have to do is 5 times 5, which is 25, and then square root of 3 times the negative square root of 3 would just be minus 3. And then on the top, you're just going to get 35 minus 7 square root of 3, and on the bottom you'll get 22. And that's your answer. And then you would do the same if, or similar if this was a minus. So if you had 8 over 4 minus square root of 5, then the conjugate would be 4 plus the square root of 5. So in the top, you're going to get 8 times 4, which is 32, plus 8 times the square root of 5, And then here, remember with conjugate, you just have to do the 4 times 4, which is 16. Square root of 5 times square root of 5. Or negative square root of 5 times square root of 5 is negative 5. So on the top, you're going to get 32 plus 8 square root of 5. And 16 minus 5 is 11. And that is rationalizing the denominator. Okay, now we're going to look at other roots. Cube roots, fourth roots, fifth roots. You may want to look at page 41 in your book because they give you the most common roots, the common cube roots, the common fourth roots, the common fifth roots. That way when you see them, you'll recognize them. So make sure you go back to that page, and make sure you look at those common roots. So that's on page 41. So when we're simplifying them, or actually let me write your common cube roots. The cube root of 1, of course, is 1. Cube root of 8 is 2. Cube root of 27 is 3. The cube root of 64 is 4. Cube root of 125. Cube root of 216. And the cube root of 1,000 is 10. So those are the most common cube roots. So when we are simplifying cubes, those are the numbers that you want to break down. So, for example, if you saw a problem like cube root of 24, then you look at what are your most common cube roots, which will, and that one would be 8. So you would break that down to 8 times 3. So the cube root of 8 we know is 2, and then the 3 will stay under. And it's very important that you write that cube root back. Okay? And then you would do the same if it was a 4. Our fourth roots, the common ones are fourth root of 1, fourth root of 16, fourth root of 81, the fourth root of 256, the fourth root of 625. Okay? So, let's say you had something like this. Fourth root of 8 times the fourth root of 4. Well, first you want to multiply them together. You'll get the fourth root of 32. Then you look in your common fourth roots, and you know that you can break 32 down to 16. So this would be 16 times 2. And the fourth root of 16 is 2. And the other 2 will stay under the radical. Okay? And look at, and you can do the same with fractions. And change this color. So if you had something like the fourth root of 81 over 16, well, 81 is a perfect fourth root, and so is 16. Fourth root of 81 is 3. 4th root of 16 is 2. Okay. And then our common 5th roots. We will see 5th root of 1, which is 1. 5th root of 32, which is 2. And the 5th root of 243 is 3. So those are the most common that you'll see with the fifth roots. Okay. Now, let's see what happens when we combine by adding and subtracting. Okay, so same thing that applies with the square roots. The radicals have to be the same, and we're only combining what's in front of the radical. So if you notice, I have a 16 and a 2. So I'm going to break this one down using 8 times 2, because I know 8 is a perfect cube. Now the cube root of 8 is 2, but there's a 5 in front. So 5 times 2 is 10. And then I'm just going to bring this down. And now you notice they are exactly the same. So 10 minus 11 would give me negative 1 cube root of 2. So it's just like combining like terms. And then you'll do the same with addition. You just have to make sure that your radicals are the same. Now we're going to look at rational exponents. A rational exponent means that it's an exponent that's in fraction form. I'm going to show you how to go from exponent form to radical form. So the way that it works is, and I'll use a common one. If you saw like 16 to the 1/2, the bottom number is always the root. And the top number is always the power. So when you think of root, you think of it like a tree. It's the bottom number. And the top, think of as power. So when you rewrite this, and this 16 represents your base. So when you write it, the 16 would go under here. The 2 would be your root, but you know we don't write 2. And then we're raising that all to the first power. So it'll look like this. And the square root of 16 we know is 4. Okay? So if you have something like this, and you rewrite it, 125 would go under here. 3 would be your root, and we're raising that all to the second power. So you always do what's in parentheses first. The cube root of 125 is 5. Then you raise it to the second power, and that'll give us 25. Now, if you had something like this, you have to be careful because remember you do this part first. So I'm going to, 4 is my root, or I'm going to raise all of that to the first power. Then I'm going to make it negative. So that'll be 4th root of 16, which is 2. Raised to the first power is still 2. Then I'm going to make it negative, so the answer is negative 2. Now that's different if they write it like this, because now they want the negative under the radical. And then I can cube root it. And then I'm going to raise it to the first power. And you know you can cube root of negative because that'll be negative 3. And then I'm going to raise it to the first power, which is still negative 3. Okay? But if you had something like 64 to the negative 1/3, then first you have to write it and simplify the negative exponent. Then you can rewrite it with 64 as your base, 3 is your root, and you're raising it to the first power. The cube root of 64 is 4. Raised to the first power is still 4, so the answer is 1/4. Okay? So just remember, if the exponent is negative, you have to put it underneath 1 first, and then you work it out. So even if you had something like this, you want to write it like this first to get rid of the negative. And then you can, 4 is the root, 81 is the base, and I'm raising that all to the third power. 4 through the 81 is 3. Raise that to the third power. I'm going to get 1/27. Okay? And then even if you're like multiplying or dividing with rational exponents, the rule still remains. That you add the exponents if the bases are the same. So the coefficients, the 5 times 7 is still 35. But with the exponents now, for the variables, you're going to have to add them, which means we have to get a common denominator. So you know the denominator, common denominator is 4. So I have to multiply the top and bottom by 2. So I'm going to get 2/4 plus 3/4, which will give me x to the 5/4. So that's the only difference with the rational exponents. Same with division. Now you know what division with the same bases you have to subtract. But you still have to get a common denominator. So the coefficients, or the numbers in front of the variables, you divide. 32 divided by 16 is 2. So the common denominator here is 12. So I have to multiply this by 4 and this by 3. So I'm going to get x to the 20/12 on the top and x to the 9/12 on the bottom. So 20 minus 9 is 11. So it'll be x to the 11/12. So that's the difference with rational exponents. You have to get common denominators to add and subtract. Okay, our last concept is reducing the index of a radical. So it's kind of like we're going to now write it as a fraction exponent. So x is the base, 3 is the power, and 9 is the root. So to reduce that, you would get x to the 1/3. And if it didn't come out evenly, you write it back as a radical. X is the base, 3 is the root, and we're raising it to the first power. Okay? second example, this would be x to the 3/6, which equals x to the 1/2. So now 2 is the root, but you know we don't write a 2. X is the base, and we're raising it to the first power. Okay. This will be x to the 12/4, which comes out evenly to x to the 3rd. And so since 1 is our root, or 1 is the bottom, it came out perfectly. So that's your answer. Okay, and then this one, I have x to the 4/12 and y to the 8/12, which will give me x to the 1/3 and y to the 2/3. So 3 is my root for both. X has a power of 1 and y has a power of 2. And then you are done. And that's it for radicals and rational exponents.